Alright, here is a quick tutorial on how to write the equation from a common parent graph. Um, First off, there are certain steps that you have to do to figure out how to graph or how to identify a common function. That's the first thing you want to do before writing the equation. So step number one is we want to identify what kind of common function this is. Well, looking at this graph, we can see that this graph right here, we are going down, all right, and it appears to be a parent function of the absolute value of x, okay? What I call the little teapot function, going like so. All right, so from there, we're going to try to identify what type of transformations are occurring. Well, we see that the function is not being shifted from the right or left because our original function, we always want to compare it to that, appears to look like that from its original. So what we see is that though it is not being shifted, it is being reflected both over the y and the x-axis. Now, reflections, or flips as some people call them, all right, are equivalent to opposites, okay, when you look at an equation. So when we see reflections, we need to put the opposite. So our new function, once we identify this graph and identify the transformations, we're going to say that we're going to reflect it. Well, since it's over the x-axis, we're going to have a negative on the outside. And we also will have a negative on the inside. We are not going to have any other transformations, either rigid transformations of right or left or up or down. So we're not adding anything to the x or the y. So that would be our first rigid transformations. The second thing we want to do, or actually the third step, is after we identify our rigid transformations, we then want to identify, do we have any non-rigid vertical transformations? Now, when you talk about common functions, especially algebraic common functions that we're dealing with here, is that rigid or non-rigid vertical and horizontal transformations are sometimes hard to distinguish. When we're dealing with different graphs, the key thing is that in order to identify non-rigid transformation, we're going to always specify the vertical because the vertical and horizontal are very, very similar. But in this case, we can only do that if we are given a point. And in this case, we are given a point. On this problem, we are given that -4, -1 is one of our points. So what we want to determine is, do we have any type of non-rigid transformation? Now, how do we do that? Well, first off, we have to identify that there is an a value, a being the amplitude and the multiplier to our f of x or to our y values. We're then going to plug in, all right, our other transformations into that function. And from here, what we want to do is we want to solve for a. Now, in order to solve for a, we need to eliminate f of x, which we know is equal to y, and we also need to eliminate x. In order to do that, we're going to take our point, which is given, all right, and we're going to substitute that into the respective places. So we're going to take -1, and we're going to put that in for f of x, and we're going to take, all right, -4, and we're going to plug that in for x, and we're going to solve for a. Now, a, once again, being the vertical transformation that we're going to see if there is one. Okay, so we're going to have this. It's going to turn into -1 equals -a, and we have the square root of 4, which is going to be 2. So we have -2a equals -1, and what we have next is going to be a equaling 1/2. So we do actually have a vertical shrink. All right, so this graph is a little bit skinnier. So we're going to plug that into our equation up here. And so our final answer for this equation of this graph, all right, of the square root graph, the square root transformation, is going to be -1/2 the square root of -x. All right, well, let's try another one. Well, here we go, is we have another function. So we're going to go through our steps, and we want to identify write the equation, all right, from the graph, all right? We're writing equations from the graph, so we want to identify first what is the common function. So common function, looking at this, is a flying v, and it appears to be the common function, parent function is going to equal absolute value of x. From here, we're going to identify the rigid transformation. It appears that from the original, which looks like this, okay, that it has been shifted down it appears 1, 2, 3 units. Okay, down 3. So that means my y values are being changed. So we're going to have f of x, absolute value of x, we're going down 3. It does not appear to have any reflections, and also does not appear to have any shifts to the left or right. Okay, so from here, what we're going to do next is after we finish step 2, is we're going to once again identify, do we have any non-rigid vertical transformations? So we need to solve for our a value. Now, it appears that we do, because this graph definitely does look a little skinnier than its original. And so I'm going to take, once again, and we're going to plug in our points. So 1, 0. 1 goes in for our x value, and 0 goes in for our f of x, because remember, f of x is our y. Okay? And what we have right here is we're going to solve for this. Well, what we have is a, then minus 3 equals 0. Add 3 to the other side, so we actually have a equaling 3. So this appears to be a vertical stretch of 3. So we're going to come back up here and change our graph. We're going to put a 3 right there. And so we have is a multiplier of 3 to the y values, and we're going to move that down 3. All right. Well, let's finish up with one where we have another graph, and we're going to find this equation. And to do this, we're going to look at this, and we're going to say, okay, what is our common function? Well, first off, our common function appears once again to be the square root of x right here. All right, because we have this. Appears to be like so. All right, this graph, once we identify our ridge transformation, let's see what happens. It looks like it's going to 1, 2, 3, 4, 5. 5 units to the right. So that means that's the square root. And I'm going to have x, and I'm going to have 5 units to the right, so I'm going to subtract that from x. And it also appears to be going up 1, 2, 1 or 2 units. Oh, just 1 unit appears. Okay. Just going to take this out. Appears to be going up 1 unit, so we're going to add 1 to the outside. And another thing is that this has been reflected over the y-axis. Well, if it's reflected over the y-axis from the original position, okay, because once again, recall, I have all those other lines, but our original graph looks like so. And it's been reflected over the y-axis. Now, reflection of the y changes the x values from their opposites. So what we're going to do is we're going to have a negative, all right, inside our x. So we're going to put a negative inside there. Place this. Now, when we do this, you have to be very careful, because we want to put this entire quantity, x minus 5, in there. And now we're going to have a negative, and we're going to take the square root of that. Okay, and that appears to be our rigid transformations. So now we go to our non-rigid. Now, our non-rigid, all right, we're going to look for vertical transformations. We need a point in order to figure this out. Now, no point is given, so since no point is given, all right, we're going to, all right, we're going to simply then just put a, because there's nothing there. We're not really sure what's happening, so we'll assume it's either 1 or some other number, but we can't determine because we don't have a point. So we're just going to put a. And we can distribute this through if we wish to each one of these terms, and we can simplify this to negative x plus 5, which you probably see in many textbooks. And this right here would be the equation for the square root function being transformed. All right, so, well, this is a quick tutorial on how to identify basic equations that's been transformed given a graph. First thing, you want to identify the common function. Next thing, identify the easy rigid transformations that have been moved right or left or reflected. And then you want to figure out if you can find the non-rigid vertical transformation by using a given point and solving for the a value, which is being the multiplier next to the parent function. So, hope that helps, and happy mathing.